Some training ideas on simultaneous equations for the summer pack. Okay, a couple of linear equations, systems of simultaneous equations, similar to the ones we've done at GCSE. And you should have done some of these as well, but just in case you didn't, let's see what's going on there. Okay. When we solve simultaneous equations and we've got two sets of linear, like here or here, there's two methods that you should be comfortable with, and you need to know them both and then choose the appropriate one depending on the situation that you're given, the way the question is presented. Okay, so this way lends itself best to elimination. And this one here lends itself probably to elimination as well, actually. Yeah, we'll do that one elimination after rearranging, and we'll do this one by substitution. Okay, so we'll do this one first. Right, substitution says we're going to get a value from one of these equations by rearranging, and then use that value to sub into the other one. Right, this one, I think we can rewrite the second equation, this one, we can rewrite that as x equals y plus 2, look, by adding the y over the other side. And then in the first equation, this one is going to turn into 2 lots of y plus 2 plus 3 lots of y is equal to 9. So where we saw that x in the question, in that equation, we've substituted x is y plus 2. So where we saw x, we can now write y plus 2. Multiplying the bracket out, collecting like terms, and then we can solve the equation and find the y value. So 2y's plus 2 2's, which is 4, plus 3y's is equal to 9. Get rid of the 4, so that all y's on one side, the number or numbers on the other side. 5y's are equal to 5, look, so y is equal to 1. And now we can sub that back into there and find the x value. So x is equal to y plus 2, 1 plus 2 is equal to 3. And there's our pair of values. Graphically, what's going on is that we've got a straight line that looks something like that. We've got another line that looks like that. And this coordinate here is 3, 1. Yeah, the x value is 3, the y value is 1. We found the coordinate of the intersection of these two straight lines on a graph. So that's the graphical interpretation. So leaving the answer as a coordinate pair is quite often something that's asked. If we leave right, what can go wrong with this? Right, a lot of students get the y value, stop. Don't bother finding the x value. Lost loads of marks. So if we always leave the answer to a simultaneous equation question as a coordinate pair, we get round the issue of forgetting to get the other value. Alright? So that's good practice. Remember to leave your answer as coordinate pair. The other thing that's very often asked, even though a lot of students go and get the y value and the x value, we'll see when we do these kind of equations, there's 2 x values and 2 y values. And they don't match them up. Students don't bother saying, right, for this particular x value, this is the y value, for this other x value, this is the particular y value to go with it. And we lose sometimes 2 or even 3 marks, even though we've found the right answers, because we didn't match them up, we lose some marks. Sometimes as many as 3, and we've done nothing wrong other than not finishing the question off. So by always writing the answer as coordinate, I want you to get that in the habit of that, so we don't lose silly marks for stupid reasons. Right? Okay. Elimination on this. Right, we're going to match up these equations. So I'm going to rewrite that one as 2x plus 3y is equal to 16. And I'm going to leave that one alone. Equals 21. Right. Do this 2 ways. The first way, I'm going to match the value of y's. So at the moment we've got 3y's there, 2y's there. But any multiple of this equation is still the same equation. Yeah, so if I do that one times 2 and get 4x plus 6y is equal to 32, it's still the same equation. If I multiply this one by 3, then 3 times 5x is 15x, 3 times minus 2y is minus 6y, and 3 21s is 63. Right, if I then add those equations together, the plus 6y and the minus 6y are going to go away. Yeah, well, they become not y. 4x and 15x becomes 19x, and 63 and 32 become 95. So 19x equals 95. I've solved it for the value of x. I've got x is 5. But I'm not finished. I need to use one of these original equations, because the numbers are easy, to get from x is 5 to the y value. So I'm just going to use the bottom one because it's there. X is 5, 5 5s are 25. Take away 4 is 21. So the 2y is 4. And so y is equal to 2. So my coordinate is 5,2. Right? Going at it a slightly different way, just to give you an example of the other thing that we can do. If I multiply this one by 5 and this one by 2, then I get 10x there and I get another 10x there. But if I multiply this, if I want to get that to 10 by multiplying by 5, I've got to do 5 everythings to get an equivalent, like equivalent fractions if you like. I can multiply or divide by whatever number I want. It's still an equivalent situation, an equivalent equation to what I started with. So 10x plus 15y is equal to 5 16s, which are 80, and then double all of them. I get 10x, take away 4y, missed the y off there, my bad, equals 42. Right. I'm not going to add these up, because if I add them up, I get 20x, and I get 11y's, and I get 122. The target for adding, or taking away as we're going to do here, is to eliminate, we eliminated the y's up there. They went away, they got 0. To get from 10x and 10x, we've got to take away one equation from the other to eliminate the x's. So that's not x's, they've gone away, we've eliminated them. 15 minus 4, that gives us 19 as well. 80 take away 42 is 38. Solving this, y is equal to 2. Look, the 2 that we got there. Oh look, did you expect anything different? Really? Sub y is 2 in one of these equations. I'm going to choose the other one just because we can. So 2x plus 3 2s are 6 is equal to 16. So 2x must be equal to 10, x is equal to 5. Right, in both of these, once we've got our answer, which we should write as a coordinate pair, get in the habit of doing that, coordinate pair, we should substitute those values back into the other equation to make sure that they work. Well, we just did this. What we didn't do, we didn't check that one. So we used this equation, didn't we, which is a revamp of that one, to get from y is 1 to x is 3. So in the other equation, we're going to sub x is 1, x is 3, y is 1, to make sure that we get 9. 2 3s are 6, 3 1s are 3, 6 add 3 is 9. It works, they're correct. And you'll see in the answer videos that I make a big point of doing the checks, and you should make sure that you checks. Right, at least one quadratic. Generally, we're going to do these by substitution way, not elimination way. Right, so in the first one, if I use the this is a quadratic one, multiplying something together. This is the quadratic one. The other one is normally linear, and we can rearrange that this linear. We don't need to do this one. This is where we see y, there, we can write x plus 1. Alternatively on this one, we can be a bit cute, and we could say, well, where we see x plus 1, because of what we're given in the question, we can get rid of x plus 1 and we can write y. Or we could rearrange it and say x equals y minus 1. Alright, we can rearrange this one just like we're going to have to rearrange that one in a second. Right, so what we've got here. I'm going to do it the sneaky way, the crafty way if you like. The x plus 1 there, I'm going to replace it for y. So my equation, this first equation, becomes y minus 2. Take away 8 and see what's not. I've rearranged that slightly, move the 8 over to this side because I can see when I multiply the bracket out, I'm going to get y squared minus 2y, take away 8. So I knew, I could see I was going to get a quad, so I've set it up. Right, this factorizes. Y minus 4, y plus 2 is equal to 0, so y is 4, comma, y equals minus 2. And this equation is what I'm going to use, because that's easy to get from my y value to my x value. Rearranging that, it says x is equal to y minus 1. So if I know my y value, x is 1 less than it. X equals 3, x equals minus 3. Alright, there's my two pairs of values, which I'm going to write as coordinates and get in the habit of doing that. And minus 3, minus 2. Right, there's my two pairs of coordinates. And it's useful to write as coordinates anyway as practice, because it reminds us about what's going on. If we rearrange that, we've got some form of a graph that looks like that. Yeah, it's not a quad. Not quite. It's kind of quad. It's a quadratic here. Look, definitely. Right. This is what I call this is the solution equation. So in the questions that you're going to have to solve, the solution equation will be a quad. Right. Y equals x plus 1 is the straight line gradient 1 that goes through 1, and it cuts our graph in two places. One of those coordinates is 3, 4, and the other coordinate is minus 3, minus 2. Right? So it reminds us by writing the answers as coordinates what the graphical situation is, what the graphical interpretation is. Okay, this one is kind of nasty because the numbers are not very nice. We're going to rearrange that to make x or y the subject. Well, I'm going to be sneaky. I'm going to say 2x is equal to 13 minus 3y, and 4x squared, which is the square of this, is equal to the square of that. So when I square this, I get 9y squared. 3 times 13 is 39, double it is minus 78y, and then 13 squared is 169. Right, going back to the original quadratic equation there, that's an ellipse. And what we've got going on here graphically is something, I'm not quite sure which way around it is. It's either that way or it's this way. I haven't done ellipses properly for a year or so, and I've forgotten which way around the 2 and the 3 goes. But this straight line goes like that, and it cuts the ellipse a couple of times, probably not on the y-axis, but somewhere. But that's definitely an ellipse. It's like a circle. You know a circle equation is x squared plus y squared is equal to y squared. So when it's not 1x squared and 1y squared, then we stretched it one way or the other. Okay, so if I double that equation and get 4x squared plus 6y squared equals 70, I can now substitute my 4x squared in, look. Alright, so I don't need to divide all this by 2. I'm substituting directly by just altering that other equation I'm going to sub in to make it neat. Right, so where I see 4x squared, I'm going to write this. So 9y squared plus 6y squared is 15y squared. Take away 78y. Add the 169, but take away the 70. Becomes add 99. That's equal to 0. But all of those values are multiples of 3, because the decimal roots of those numbers, 1 and 5 makes 6, 7 and 8 makes 15, 9 and 9 makes 18. So they're all multiples of 3. So 5y squared, take away 26y's plus 33 is equal to 0. And now it's a bit easier to solve. 5 33s is 165. And factor of 165. 2 don't go into this. 3 does. Is it? Yeah, 3 does. 53 times. 4 don't. 5 does. 33 times, because we know that. 8, 9 doesn't. 10 doesn't. 11 does. 15 times. And 11 and 15 adds to 26. So this is 5y squared. 5y in each bracket. 5y. Both the signs are the same, they're both minuses. 11 and 15. So y is equal to 11 over 5. Or y is equal to 15 divided by 5, which is 3. Right, there's our y values. We haven't finished because we need the coordinates. And we get our x coordinates by considering the easy version. And the easy version is what we started with in that question there, but we rearranged it slightly. 2x was equal to 13 minus 3y So if y is equal to this, 2x is equal to 13 minus 33 over 5. So x is equal to that divided by 2, and the other one is 2x is equal to 13 minus 3 threes, which is 4, divided by 2 is equal to 2. So when y is 3, x is 2. When y is 11 fifths, 65, 32, 16 over 5. So x equals 16 over 5. So our answers are 16 over 5, comma 11 over 5, and 2, comma 3. Alright, as coordinates. What we do then, before we move on to the next question, is sub both the values, so 2 and 3, first of all into the difficult one, and then sub the other two into the difficult equation and make sure it all works. I'm not going to bother doing that, I'm quite happy that's our process. If you made any mistakes and it didn't work, to show that you made any mistakes, then you need to start again and do it again. Alright, but we should always check our answer. I'm not going to for speed. The idea of this video was to give you some idea of our process. Part of the process is to check, and I'll just explain that in under normal circumstances, so I'm not going to waste your time. Right. The solution equation, as I call that one, is the one that we've got there. That's our solution equation. That's our raw solution equation. We actually solved a version of that by dividing by 3 because that was a lot easier.